Children, I had explained you different types of hybridizations by my past videos. So, three types of hybridizations. Do you remember? sp3, sp3, sp2 and sp related with carbon atom. In detail, I had explained you how it forms, after the formation, what is the arrangement. All the details I had explained you according to the new A-level syllabus. Right? Today, I am going to explain you the other type of hybridization related with the phosphorus atom. It is not needed in detail in our syllabus, new syllabus. It is enough to know just, right, to explain what is the type of hybridization. That is enough, right? Then, so consider the phosphorus atom, P-atom. What is the atomic number of P? 15. Atomic number is 15. So, at the ground state configuration, it is the 1s2, 2s2, 2p6, 3s2, 3p3. This is the ground state configuration of phosphorus atom. So the outermost energy level is third energy level, 3s2, 3p3. Then you know that not in carbon really. Carbon has the outermost orbital, outermost energy level, second energy level. Second energy level has two types of sub-energy levels, S and P only. But in this case, phosphorus has the outermost energy level, third. So there are three types of sub-energy levels, S and P and D also. D sub-energy level also present in third energy level. Right? This is the difference between carbon and phosphorus. This is the ground state configuration. According to that configuration, 3s2 spherical orbital has filled, 3p3 three dumbbell shaped orbitals. They are having one electron in each. That's all. According to this configuration, it has the possibility to form only three covalent bonds because P-atom has at the ground state configuration 3 orbitals with one electron in each. Right? So, then at the excited state, the one electron of the 3s orbital transfer to 3d orbital. I told you P has 3d. How many orbitals? 3d sub-energy level has 5 orbitals. I had drawn one, then one electron of 3s orbital transfers to the first orbital of 3d sub-energy level. because no electrons in the 3D, right? Then I have to tell you this type of hybridization not need in detail, not need to study in detail for you, because 3D, the shape of the 3D orbitals are not need to study according to our syllabus, right? Therefore, only I will be going to explain 3D orbitals as shown in the general configuration, general representation. Not consider the shape of 3D orbitals, right? Then, after the excited state, what was happened? 3s orbital has one electron, 3p orbitals are having one in each, d orbital also having one electron. This orbital, one electron here, 3d. Then it is clear that after the excited state, 3s, the lower energy level of the main energy level, third energy level, 3s is the lowest, little above 3p, higher energy level 3d, all are at the third energy level. But these are different in amount of energy as well as shape also. S orbital has spherical shape, p orbitals are having dumbbell shape, but 3d also having another shape, not need to know. Then after the excited state, you know that it is clear the hybridization should be completed. These three types of orbitals come together to the same energy level and same shape. We are not explain here because not need to know the shape of 3D orbitals, right? Anyway, they undergo the hybridization, come to the same energy level with the same shape, forming SP3, PX, PY, PZ, and D also, D1. All are come to the same energy level and same shape. So we can explain that type of hybridization as SP3. All the three orbitals are participated with D also, D orbital. Then this type of hybridization can be explained as sp3d type of hybridization. How many orbitals are formed? S orbital, 3p orbitals and 1d orbital. All together 1, 2, 3, 4, 5. There are 5 orbitals with the same shape and same energy. Right? Then, after the hybridization, how they arrange around the nucleus of phosphorus? If this is the nucleus of phosphorus, 3 orbitals are arranged like this. Do you remember sp2 hybridization of carbon atom? They are arranged at the same plane, right? Same plane. sp3d, sp3d. This also sp3d. This is the nucleus. So angles 120. Angles 120, 120 at the same plane. Do you remember sp2 hybridization of carbon atom also? Similarly, there are three hybridized orbitals. They also arrange at the same plane to give the trigonal planar shape. Then, where are the other two orbitals which are hybridized sp3d? One comes perpendicular to the trigonal planar, like this. These are the electrons. Other one also lies like this, perpendicular to the plane. These two are perpendicular to the trigonal planar. So there are 5 orbitals, all are identical. sp3d, all are identical each other. Right? Then I can show a model of this arrangement. Like this. See here. These are the 3 orbitals at the same plane. This is the same plane. 3 orbitals at the same plane, giving the 120 angle. The other 2 perpendicular to that trigonal planar. Now how many angles? 120 angles, 320 angles with this orbital perpendicular 90 degrees. Here one, other one here, 3 90-degree angles. Below also 3 90-degree angles. Altogether, that arrangement has 123 angles and 90 degrees. 1, 2, 3, 4, 5, 6 angles. This is the arrangement. Then we can explain that arrangement giving a suitable name, particular name. So see here, if we combine these atoms after the formation of molecule, so triangular base, this is the triangular base and pyramid. This is the pyramid, trigonal pyramid. That pyramid has 3 faces with the triangular base. The below also having trigonal pyramid. How many triangular pyramids? 2 triangular pyramids on the common plane triangle. So it is named as trigonal bipyramidal. Bi means 2. Trigonal bipyramidal. This arrangement is explained as the trigonal bipyramidal arrangement. This is the arrangement of the hybridized orbitals around the phosphorus atom. Do you remember? sp3 of carbon tetrahedral, sp2 trigonal planar, sp linear, sp3d trigonal bipyramidal. Then after that, what the molecule can be formed? What the molecule can be formed? As an example, PCl5, phosphorus pentachloride. Chlorine has 17, 1s2, 2s2, 2p, 6, 3s2, 3p5. This is the ground state configuration. Then third energy level has 3s2 and 3p5. What is the arrangement of the 3p5? 3p. So the 3p, you know that it is 3d x axis, y axis and z axis, 3d, three-dimensional arrangement like this. Along y axis, py orbital. Along x axis, px orbital. Along z axis, pz orbital. These are the arrangement of 3p5. 3p, 5 electrons. Then 1 electron, 1, 2, 3, 4, 5. That's all. These two orbitals are filled with 2 electrons in each. This one has only 1 electron. Then this orbital can be bonded with sp3d hybridized orbital of phosphorus like this. This orbital comes here of the fluorine atom, this is the nucleus, this is the fluorine atom, and linear overlapping forming sigma covalent bonds. Similarly, other atoms are possible to form like this. One, two, three, four, 5. All are sigma covalent bonds with phosphorus nucleus, 5f atoms. This is the arrangement of the molecule. So, these are the hybridized 5 orbitals. They join with, overlapping with fluorine atoms with the p orbitals. 5 are joined around the trigonal bipyramidal arrangement giving PFPCl5 phosphorus pentachloride. So the shape of the molecule also trigonal bipyramidal, right? This is the fourth type of hybridization related with the phosphorus atom, right? Then, not in detail, but that subject matter you must know about the sp3d type of hybridization related with phosphorus, right? Then we have to study only one type of hybridization. Altogether five types. It is related with the sulfate. From my next video, I hope to explain you the last type of hybridization recently. Right? I think now you are able to understand very well the fourth type of hybridization. It is the sp3d type of hybridization related with the phosphorus atom. Then, after the hybridization knowledge, I hope to explain you shapes of the molecules and what is the relation between shape and the hybridization type. From my next videos in future, I hope to study you, teach you, with you in future. Thank you so much, my dear children. Please subscribe me. Thank you again and again.